Hi there, I'm Kelsey, and I'm a scientist at the University of Minnesota. Today I'm going to tell you a little bit about how we might be able to combat obesity by using my research, where I learn about how cells, which are the building blocks of our bodies, can change what they're doing in response to a specific need. Obesity affects all of us, and I'm not just talking about the 3 in 20 of us that are obese, or even the 8 in 20 of us that are overweight. I'm talking about the economy. In 2008, it was estimated that obesity costs the U.S. about $147 billion a year. And when we adjust for inflation, that's more like $173 billion a year. So how do we fix this? Of course, eating better and exercising more could help us lose weight, but maybe we can do something a little bit more. Maybe we can develop a medicine that could help us battle obesity. So to understand how my research could help us in the battle against obesity, we first have to understand how the cells in our bodies do things. We can think about cells as kind of like factories. Materials show up at the factories, they go inside. Workers then follow instructions and make things like cars and trucks. So now imagine that you are the manager of one of these factories and you've given your workers blueprints for making cars and trucks. About 50% of them have blueprints for cars and 50% have blueprints for making trucks. So they're going along, they're making their cars and their trucks, but then you decide that now you don't want to make any more cars, you need to make minivans instead. But you still need to make some trucks. So how do you get your workers to change what they're doing? Well, you could send someone around to take away everyone's blueprints and then hand out new ones. But you already have people making trucks, so that seems like extra work. You could send someone to just take the blueprints for the cars and replace them with blueprints for minivans. And that's basically what our cells are doing every day. Our cells have a group of workers called ribosomes that follow blueprints to make various machines called proteins that all have specific jobs. And some of those jobs are things like helping our cells to absorb fats from our diet, or using those fats, or packaging those fats for storage in fat tissue. My research is focused on a particular protein called nocturnin that we think might go around finding and destroying the blueprints for proteins that make fat, that use fat, making ribosomes available to make proteins that promote fat storage. We know that special mice that don't have nocturnin can eat a fatty diet and not become obese like a regular mouse. Now, of course, that's just in mice, but what about in humans? Well, we don't actually know. When we're talking about how cells work, mice and humans have a lot of similarities, but they also have a lot of differences. So it's a bit early to say, oh, we should just get rid of all of the nocturnin in humans, and then we can eat all the cheeseburgers we want and be skinny. Instead, we should learn a bit more about nocturnin first, because maybe in humans it does something else, or maybe it does other really important jobs that we wouldn't want to mess up. So in order to learn about the human version of nocturnin, I'm trying to answer a few specific questions. First, which blueprints is it going around destroying? Second, how does nocturnin know that it's found the right blueprints? And once it's found those blueprints, how does it destroy them? We don't actually know the answer to any of these questions, but knowing that would be extremely helpful. And maybe by answering these questions, we can learn if nocturnin plays a role in human obesity, what that role is, and then maybe we can design a medicine that could help us lose weight when we use it in combination with a healthy diet and exercise.